Hey, welcome to The Explainer. Today, we're going to pull back the curtain on the hidden system that powers, well, pretty much everything you do online. I mean, it's something we use every single second, but we almost never think about it. So let's just dive right in with the big question. What is a network, really?
Okay, so just think about this for a second. You type out a message, you hit send, and bam, almost instantly, it pops up on your friend's screen, who could be halfway across the world, right? It totally feels like magic. But it's not. It's actually this incredibly complex, super high-speed journey. So what really happens in that tiny little split second?
Well, the answer to that question, what happens when you hit send? It all starts with understanding the system that connects every one of us, the network.
So, at its absolute core, a network is actually super simple. It's just a system that lets at least two devices connect and talk to each other. I mean, that's it. Whether you're sending a quick message, streaming a movie, or, printing a document, the whole point is always communication. And that one simple idea, it's the foundation for literally everything we do online.
Okay, so if a network is all about communication, then who's doing the communicating, right? Let's meet the key players in this whole operation, the actual devices that make it all happen.
All right, so all the devices on a network basically fall into two main groups. On one side, you've got the devices that actually create and use the data. On the other side, you've got the devices that just move and direct that data. It's a really simple distinction, but believe me, it is absolutely crucial.
So in that first group, we've got what we call end devices, and these are the ones you and I touch and use every single day. We're talking about your computer, your smartphone, even your printer. They're the starting line and the finish line for any piece of information that's sent. They are the senders and the receivers.
And then on the other team, we've got the intermediary devices. You can totally think of these as the traffic cops of the internet, the digital postal service, right? Devices like switches and routers, they couldn't care less about what's in your message. Their one and only job is to get it where it's going safely and as fast as possible.
Okay, let's zoom in on two of the most important traffic cops, a switch and a router. A switch, think of it like a mailroom sorter inside one single office building. It knows exactly which desk to send a letter to, as long as it's inside that same building. A router, though, that's like the city's main post office. Its job is way bigger. It connects your entire building to other buildings, other cities, even other countries. It's the one that figures out the best possible path for your message to travel a long distance.
All right, so we've got our players, we know who's sending the data and who's directing it, but how does that data actually travel? I mean, what are the physical roads it takes on this journey?
Well, this whole journey happens on what you can think of as digital highways. We call them network media, and there are a few different kinds. Data can travel as little electrical signals through the copper cables that are probably in your walls right now. Or it can be pulses of light, just zipping through super fast fiber optic cables buried under the ocean. Or, of course, it can be the invisible radio waves we all know and love as Wi-Fi. Each one is a totally different kind of road, built for a very specific purpose.
But here's a really critical detail. That video you're streaming right now, it's not traveling in one giant unbroken stream. Oh no, the network is way smarter than that. It takes everything, your video, your emails, your Google searches, and it breaks it all down into thousands of tiny, manageable little pieces. And these pieces are called packets. You can think of each one as a single piece of a giant puzzle.
And this is the perfect way to think about it. A packet is basically a digital envelope. Inside is a little chunk of your data, that's the letter itself, but on the outside you've got the addressing information. And that address, that is the only thing the routers and switches care about. It tells them exactly where to forward that little envelope next.
Okay, so we have our traffic cops and we have our digital envelopes full of data, but where is all this traffic going? Let's zoom out a bit and look at how these networks scale, from the one that's just in your room to the one that literally covers the entire world.
So networks pretty much come in two main flavors. The one you're probably on right this second is a local area network, or a LAN for short. That's your home Wi-Fi network or the one at school or the office. But when your data needs to go somewhere else, like outside your house, it jumps onto a wide area network, or WAN. And a WAN is really just a huge network that's designed to connect a bunch of smaller LANs together over long distances.
And this brings us to a really important point. The internet, it's not some magical, abstract cloud up in the sky. It is, very simply, the world's biggest WAN. It's a massive global network made up of countless smaller networks, all speaking the same language so they can guide our little data packets around.
And the scale here is just mind-boggling.
I mean, we are talking about billions and billions of devices. Computers, phones, servers, smart toasters, you name it. They're all connected and talking to each other across this one gigantic global network. And every single one of those little packets we talked about has to find its way through this incredible web.
So, why did we just go through all of that? Why does any of this matter? Well, because understanding this stuff isn't just for networking nerds. It's about understanding the basic architecture of your digital life.
Think about it. Every single time you send an email, every time you watch a video, every time you search for anything, you are kicking off this exact process. Your request gets chopped up into packets. Those packets are guided by switches and routers. They travel across cables and through the air. They move from your local network to a wider one, all to get to their destination. It happens every single time.
Okay, so let's do a quick recap. The 4 big things to remember. Number 1, networks exist for one reason, to let devices communicate. Number 2, you've got 2 teams of devices. End devices use data, and intermediary devices just move it. Simple. Number 3, all your information travels in those little digital envelopes called packets. And number 4, networks scale up, from the local one in your house, the LAN, to the huge global internet, the WAN.
And look, this isn't just a fun fact to know. This knowledge is truly the foundation. If you want to understand anything else, like cybersecurity or cloud computing or even just why your Wi-Fi is acting up, it all starts with these basic building blocks.
So when you step back and look at it, we've built this absolutely incredible system on just a few simple rules, right? Break stuff into packets, slap an address on them, and let the traffic cops do their job. It's this beautiful paradox, a system of mind-blowing complexity, all built on a foundation of profound simplicity. And it really makes you wonder, if we manage to connect the entire world with just a digital envelope and a good set of directions, what can't we build with it next?